Let's work with covalent bonding, starting with the easiest diatomic molecule I can think of, and that would be hydrogen, molecule of hydrogen. You all know that hydrogen has one valence electron, so I'll represent that one valence with one dot. Now I'm going to get another color here and make another hydrogen with its one valence electron. And I'm going to put that right in between. The two electrons are right in between the two symbols. And that represents the covalently bonded electrons. So if we look at it from the viewpoint of the red hydrogen, it has two valence electrons and it has a full octet. I know octet means 8 and hydrogen only has 2, but hydrogen is so small. Remember, it only has the first energy level, which holds only 2 electrons. The blue hydrogen also has its octet complete. So right here, we have what we refer to as a shared pair of electrons, and that represents the covalent bond. Fluorine's a little more complicated diatomic because it has 1, 2, 3, 4, 5, 6, 7 valence electrons. So if I also draw a blue fluorine, it also has 1, 2, 3, 4, 5, 6, 7 valence electrons. And what do I have here? I have 2 electrons in the middle, and that gives 1, 2, 4, 6, 8 to the blue fluorine, and 2, 4, 6, 8 to the red fluorine. So both of these have completed their octets by having a shared pair of electrons that represent a covalent bond. The formula for methane is CH4. There's 1 carbon and 4 hydrogens. How would we draw a dot diagram for that? When you look at a formula, you usually start with the singleton, the one that there is only one of, and that would be the carbon. And carbon has 4 valence electrons. Looking on the periodic table, we see that where it is in the group, and we know it has 4 valence electrons. Now, it's going to bond with 4 hydrogens. Hydrogen has 1 valence electron. And you see we have a shared pair when we added 1 hydrogen. Let's add another hydrogen, bonding with a different valence electron for the carbon, and another electron bonding with another hydrogen bonding with a different electron on the carbon, and a 4th hydrogen bonding with the 4th valence electron on carbon. So now you can see that we have 1, 2, 3, 4 pairs of electrons, or 1, 2, 3, 4, 5, 6, 7, 8 total around carbon. So carbon has a full octet. Hydrogen has 2 valence electrons now. Remember, it only had the first energy level, so it only has room for 2 electrons. Would represent the methane molecule as a dot diagram. The formula for water, H2O, makes water be our singleton. And water has 1, 2, 3, 4, 5, 6 valence electrons. We're going to add a hydrogen where we have an unshared pair with its single electron, and we'll add a second hydrogen where we have another unshared electron on oxygen. And now you can see that we have 1, 2, 3, 4, 5, 6, 7, 8, an octet for the oxygen, and hydrogen has completed its duet, if you wanted to say that, in the first energy level, both of them with a pair of electrons. In this, we have 2 covalent bonds, one right there and one right there. And we have 2 unshared electron pairs, one right there and one right there. Let's contrast that with the methane. We have 4 covalent bonds, 1, 2, 3, 4, and no unshared pairs.